Hello, everybody, and welcome to a new episode of Zed Decoded. Today, I have with me Nathan and Antonio, two of the three co-founders of Zed, and today we're going to talk about text coordinate systems. I don't know if that's an established term or we made it up, but I think it's fitting for this episode. So, what I want to talk to you guys about today is basically the question: where is the cursor, or what are locations in text documents? How can I find out, what are the drawbacks of different coordinate systems for text, and what can we use for which purposes? So to kick things off, I prepared this little test here. It's in the editor tests, which is, I didn't believe it, but it's actually 12,000 lines of code. It's a pretty long file. So this is just to walk everybody through this, the viewers. So, normal test, blah, 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 some test setup. And then here we say set state, which basically says this editor or a editor has the following state, which means this document and this little symbol here, I think it's a little Unicode symbol, says the cursor is here, right? So in line 0, because we're programmers, 0 index, line 0, at the start, this is the cursor. Then in the test, I change or update the editor to change the selections and select ranges. So a range is 2 points, right? And I select from point 0, 1 to point 0, 3. And that means 0, 1 means line 0 or row 0 and column 1, also indexed by 0, and then row 0, column 3. So this is what I then end up with, that this is the editor state, and these little symbols here mean selection. So basically, this text is selected, these two characters. And then down here we also say selection ranges 1 to 3. And these are offsets, these are absolute offsets. So my question to both of you, what's wrong with points? Why isn't this good enough? A point, a row, and a column.
What's wrong with them?
Yeah, like why, when you look through the Zed codebase, let's see if there's I think there's stuff in here. If I look through the rest of the codebase, there's anchors, which is a type of text position. Point for position. There's, I think, display points. There's offsets, UTF-16. There's all of these things. Why?
Right.
Why is this not enough?
Why so many coordinate systems? Why not just have points? Why are there so many ways of representing position in Zed? I mean, I think there are a lot of cases where like offsets or points could potentially be used interchangeably, but there are also cases where, offsets carry more information, if that makes sense, because if you think about like an absolute offset in the file, doesn't really care about new lines. Whereas and so you can do things with offsets like relative to one another that you just can't really or Antonio, is what I'm saying make sense actually help?
I think each could serve different purposes. Like one example that comes to mind is like moving right or left versus moving up or down. Like if you move, say that you have your cursor at the end of a line, right?
Yeah.
Moving right should move you to the next line. Now, if you use offsets, that's like very straightforward. You just say, whatever offset I'm at, +1, and I go there, right? But like, say that you wanna, if you wanted to do that with points, I mean, I guess you could still do that pretty easily. But like,
you get the length of the line, or right?
Right, exactly. Like that's kind of, it's trickier. Now, the opposite is true for moving up or down. Like if you have points, right? Like if you want to if you're at row 2, and you want to go down, well, with points, it's super straightforward. You could just say, increment the row count, right? Like and just go to point 3.2. Whereas with offsets, you would need to do some math in order. So I think, I don't know, one answer for the question of why we need all these coordinate systems is that each serves a different purpose. Like another example is like UTF-16, like why, we store characters in the buffer as UTF-8. Like
Yeah.
one reason for like indexing in UTF-16 coordinates is that the language server speaks, like many language servers. I think
Yeah.
the default,
Yeah, the
like
protocol says UTF
right.
16. Yeah, yeah.
So it's convenient to be able to kind of index into that coordinate space because then we can just talk the way they talk.
Okay. So let's
And anchors
Go.
are a whole other story, right? Anchors are like,
yeah, let's
Yeah.
we'll get to anchors, but let's not right now. So
Okay.
here, let's talk about this test move cursor, which is also in this file. And I think here, move down, right? I think this is kind of what you were talking about, except this is trickier. This is already more complicated, right? Because we suddenly have display points and we have invisible characters. But I want to first look into this, move down. So this is basically, I think, what you were talking about, Antonio, right? Like, what if you hit, arrow down, or what if you hit J in the mode? And so what does this do? Let's walk through this code. So basically, selections for everybody viewing, and you can correct me if this is wrong, everything in Zed is a selection, right? Even if you have a single cursor, that's a selection.
Correct.
With
that's
where
an empty selection.
the head and the end are the same position, basically, I think. So movement down by rows. Here we go. Okay, what is going on here? This is
Probably a lot more than the simple story that Antonio told.
yeah.
Right. Yeah, I simplified things a little bit, probably.
Yes, this is all of it is in here, right?
Yeah, because there's also like spatial stuff going on to take care of like intuitive cursor movement across variable width fonts. So that kind of blows that up a little bit. There's the fact that, we're in display coordinates, but that's its own thing. But then there's goal column management as well, right? The idea that like when you're moving up and down on the end of a line from a longer line to a shorter line, when you move down again from the shorter line to a longer line, you want to, jump back out to that spot. So that's this goal column stuff. There's a lot involved in even moving the cursor up and down.
I
Yeah,
see.
I mean, you could also, and not necessarily like where you want to park your cursor is a valid spot, and so that's where clipping, you'll see like clip point in there, like that's a way of kind of parking the cursor at a spot where you can actually type. I don't know, we could go through this like top to bottom.
let's.
But,
I mean, so the way I understand, let's go back to my test here. So we have points, right? That's if we look at the definition of point, it's a row and it's a column, and they, unsigned U32. So as simple as it gets. And then here the selection.
Although, how do you
What?
add 2 points? But anyway, they're
Okay.
it's not obvious what a point is, and it's not the same thing as a point on a Cartesian plane, which often surprises people.
Go on.
Well, like with a Cartesian point, you would add the rows and add the columns, right?
Yeah.
But in Zed, or in text coordinate system, it's different. Like the definition of addition would be basically like if you were adding 0 rows and some number of columns, then you would add to the column. But if the right side of the expression has a non-zero row, then you interpret that as the number of carriage returns to append to whatever line the point on the left is theoretically on. And then the columns represents how far from the 0 to move forward. So it's this kind of quirky definition of even addition for the point.
So meaning, in my words, if you have a point, row 5, column 8, and you want to add 2 rows and 8 columns, whatever, that you cannot just add those together. You actually need to find out, how long that. You first need to add the rows, I guess, and then you need to find out how long that row is and whether the extra columns will bring you to the next one, or...
No, you actually just add the... Yeah, so here, are you in a buffer somewhere where we could literally sketch this out? Yeah. So it's like, I just want to hijack this test for a second.
Yes.
And I would say point new, and so what you're saying 5.
Yeah, 5 and
8?
8. Yeah.
And then we're going to add point new 2 8, right?
Yeah.
Thank you. And then assert EQ. That will be point new 7 8. Because what we do is we essentially we're interpreting it as like this is sort of summarizing how many new lines are in a piece of text and then the trailing characters on the last line. This is sort of like number of new lines, length of last line.
Yeah.
Really what it is.
One way of expressing it is like those two, like the 2 and the 8 are actually expressing two vectors. Like 2 expresses like go down by two lines, and then like 8 means go right by 8 columns. I don't know if that helps clarify it, but yeah, it's not
typewriter.
It's a typewriter, right?
Carriage returns.
Okay, so how do we get to the next abstraction layer, which I think are display points? Like I saw tests. Let's pull them up maybe. Display map. There's we don't have to go into the display map. I just want to find these tests because they look scary because they have all of these things here, right?
Emojis.
Yeah, these emojis, right? So what does that have to, like, it's emojis, it's tabs, and what I know is that emojis, how do I express this? Say that family emoji with the 4 people in it. That's 4 bytes, right? So if you use like a dumb offset, a byte-based offset, you might end up saying the position of the cursor is in the middle of these emojis, which is wrong. So you kind of need to be aware of that, which is, I guess, UTF-8, right? But then, I don't know, like that's where I'm lost. Like, but if I look at these tests and then I see the emojis, I see the invisible characters, and I see display point, I'm wondering, is that what this is about? That display point is, I don't know, what you see versus...
Exactly. Like \T is never what you're going to see on screen, right? Every time there's a \T in the buffer, that is between 1 and up to your tab size characters, right? It's on screen that are injected, synthesized into the file, basically, to kind of line things up on the next tab stop. And so a display point is a coordinate system that has those spaces injected. Now they're atomically injected, so a display point would need to be clipped, essentially. Like not every column in the display coordinate system is actually valid. So because it might be in the middle of one of these expanded tabs, and that's what clipping's all about. But fundamentally, like when you see display, it means all of that rendering has kind of been expanded.
Got it. Okay, so what's happening here is let me go to the start of this test maybe. So this is the text, emoji, tab, Unicode character, new line, blah, 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 lots of stuff. And then here we build a display map, which I guess for our purposes here is the thing that indexes this text and has information about what, how certain things are displayed. And then here we say, give me a point, which is a multi-buffer point, which is also, it's an alias for point. So that's also, I think, row and column, right? Yes. Mm-hmm. So we say here, give me a new point in row 0, and then its position is after the emoji and the 2 tabs, right?
Yep, that's correct. We're basically, in this case, kind of counting bytes, right?
Yeah.
Yeah.
Okay, and then we assert that this point convert it to a display point using our display map, gives us this display point, which is emoji and then these spaces here, right?
Mm-hmm. Yeah, so note how we basically have expanded out the tab, right? The 2 tabs to the nearest tab stop.
Yeah.
And count the spaces. I'm imagining it's kind of an interesting
1,
count,
2,
right?
3, 4, 5, 6, 7.
7. That's because we have the emoji, right? So if we have a tab length of 4, the emoji sort of consumes 1 of our characters, and then we expand 3, and then there's an additional 4 for the next tab stop.
Okay. And where's the tab length stored? It's in the display map, I would assume, right?
Yeah, it seems like we're not passing it in this case, but yeah, it is a parameter that you can tweak. I think right now it's kind of
The default?
we read it from the settings. I think each language has a different tab size, I believe, and so yeah,
Okay.
it's kind of a setting. So yeah, it's dependent on the language.
And so
Okay.
note, though, that there's like display points in the middle of that tab, right? You could have like display point 0, 2 or 0, 3, right? Which would be in the middle of the tab. But you can't actually like put your cursor there because we apply this process that Antonio mentioned earlier, clipping. And then you choose a bias when you're clipping as well. Like, okay, if I'm in the middle of a no man's land, the middle of an expanded tab, not really a valid position in the buffer, which way should I go? Should I go to the start of it or the end of it? That's controlled by the clipping bias.
So where does that happen? If I have the point and I convert it to a display point, I mean, then I guess it doesn't happen, right? It happens when you go back, when you want to go...
The other direction.
Yes. So if I have a display point, and like you said, we had 7 spaces here, right? So I could also remove 2, and then when you go back to point, that's where the clipping comes in, because then it
Yeah,
says...
it looks like in this 2-point method, we just always fix the bias to left. But there are cases where we don't do
This?
that.
Okay. Oh boy, here. 2 grab point, 2 tap point, 2 fold.
Yeah, like I think one way of thinking about it, like the reason why we have a bias is that it's a way of conveying intention of the user. Again, in the movement example, like if we try to move right and we land into one of these, expanded tabs, like we want to bias to the right because the user wanted to go forward, right? Vice
see.
versa, like when the user is trying to move left or up, like we want to bias left. Like we want to put you kind of before, the user wanted to travel backwards, and therefore like we want to bias to the left. So that's where
Okay.
the more explicit bias comes in. Like we kind of can clip more precisely.
So in your case, like if I were before tab with 8, tab with 8 or whatever, and I hit right, I don't want to end up in there, but the bias is, we know that I ended up on this one tab thing, right, on one tab character, but I cannot land in the middle of it, so you say bias right, so you skip
Correct.
over the whole thing.
Correct.
Which is also what happens here. Like if you look at my screen, when there's inlay hints, right, I think, where you jump over these inlay hints, and you skip that.
Correct.
Okay.
Are
So-
you sharing your screen? Are you...
Yeah. Well, I don't. Well,
I think it was showing-
You'd have to switch windows, I think, to.
Yeah, it's in Riverside.
Yeah.
I
Sorry.
see. Not in
Okay. So we have point, row and column. Offset can also be handy. It's saying it's not, one isn't better than the other because for different purposes, one might be easier to work with than the other. Display point is then about everything that we see, where, the invisible characters or characters of different width. Do fonts also play into this, like ligatures and stuff like that, or is that? Because I noticed here in the, where were we? In this tab, we say here display map, and we say Helvetica as font and font size.
Yeah, I think they matter in terms of like when we move. Like I think Nathan was alluding to that earlier in the sense that like like say that you are at 0.33, right? And
Yeah.
you want to move down. Like the naive thing to do would be to say, okay, I'm gonna move the cursor to 0.43.
Yeah.
But like that may not line up spatially because, you know, the character displayed on one line might kind of render very differently from the characters displayed on the other line, even though the number of bytes might be the same. And so I think that's where like the font-based stuff come in. Like I think in here, if you look,
Follow you.
yeah, in the movement, when we say down by rows, in
Yes.
some cases, I forget exactly like in which cases, but like there are, I think that the default case actually is that we do this like X for a display point where you can see like there's a start and like text layout details. So what that is doing is kind of calculating like an actual pixel amount so that we kind of park you in the spot that looks visually correct. And so that could be that like you jump from 3.4 to like 4.6, like even though that's not, you know, the exact math, but like it's what makes sense visually.
But I don't, and I think the font plays a role in soft wrapping. Although we don't perform like full layout for soft wrapping. It's sort of faked a little bit by just measuring in like, yeah, the width of the characters. We don't do like a full-on harf buzz situation for that because it would be too slow. But for the most part, the font isn't a factor. I think it's becoming more of a factor as things get potentially more sophisticated, but I don't know exactly where else it would come into play. But mostly we try to keep things abstracted as bytes and characters and not be thinking about the spatial layout as much as we can.
Yeah. I don't think I've ever ran into this, to be honest.
Another notion that we have is the notion of a grapheme.
Okay.
And I think this was contributed to by the community. Like if you look at how clipping works in the rope, because like again, clipping kind of stacks up, meaning like, you know, one thing we didn't mention is that yes, we have points, and then we jump to display points, but like there's a bunch of layers in between of like other, you know, like each transformation, like expanding tabs, that's kind of its own coordinate space. Then like we soft wrap, that's its own coordinate space. Like they all stack on top of each other. Like at the very bottom, there's the rope, which we talked about during a previous session. But yeah, like one way that we do clipping is by using graphemes. So like we kind of, like basically characters, like in Unicode, like there's a notion of like a code point, but like that's not necessarily like the kind of, you know, most kind of intuitive unit to navigate. Like in characters like CJK, like Chinese, Japanese, and Korean, like sometimes like you want to care about the grapheme, which is like a more like a bigger cluster that makes sense to navigate back and forth. And so yeah, you can see here like we're using this grapheme cursor to kind of determine whether or not when clipping we are at a boundary. If we are, then we're fine. You know, the clipping is done. Otherwise, we kind of advance or go backwards.
So basically what I said earlier was wrong, right? That the emoji stuff, so that you don't end up in the middle of an emoji, that's not happening on the display map layer or on that abstraction layer. It's happening here, right? Like if I mean, we're in the rope file, right? So this is, I guess, well, there's one more layer down there, there's something, but as low as it gets for this. And you say, give me this, clip this point, which is a row and a column, and with the following bias. And then here, I looked at this code, I reviewed some of this. So he would say, do we have, like, build a grapheme cursor, which is a different coordinate space, like you said, and then we check, are we on a character boundary? And if so, we move the cursor to one direction or another, right?
I think so. I think this is kind of like, and then there's the grapheme. Like there's a notion of a character boundary, and that's like standard Unicode. Like you can basically, based on a position, you can determine whether or not in UTF-8 land you're in the middle of a multi-byte character. But then there's also, and I think the reason why these two ifs are stacked this way is so that I think it's more efficient. Basically, like we only consider the graphemes if we are inside of a chart boundary, not at all times.
Yeah. There's.
Yeah, we didn't write this code. This is like,
I know. But Conrad and I looked at it, and things are not that easy. It's I don't want to talk out of my ass because this is recorded, but the whole is this a boundary thing is pretty like complicated actually, and you cannot do it that fast because there's lookup tables and whatnot, and stuff is.
I wonder what the overhead of adding this was.
It was pretty big.
It? Okay.
Yeah, we looked at it, we profiled it, and it's I think this was for certain things wrapping like 20% or something, and then Conrad and I were reviewing the PR and thinking, why is this so slow? And then you look around and you figure like this library that we're using here, Unicode segmentation, I think it's this one. Basically, this is as good as it gets. They're saying 20% is good for if you want to do this. Like if you want to find out whether you're in the middle of an emoji, you have to pay a price, and as you know, it's not that simple.
Crazy.
Yeah. Okay. So.
Yep.
Sorry, you want to say something?
Oh, I was just wondering, like, should we? I don't know. I'm getting into implementation thoughts. Like, could we flag this behavior on the presence of something that we know as a grapheme, so that we skip it in the ASCII only case? But then emojis are pretty common. When you mentioned emojis, I was like, that feels, and there are languages that use these tons, right? But if you're just in ASCII, you never do.
But I think one thing we could do pretty easily. Yeah, again, we're in implementation land, but let's talk about it. Yeah. It's like, we are inside of a chunk. Like we could index this in the rope and have like at the cost of an extra boolean say, well, like in this region of the code, like we have a grapheme, so like let's pay for that. Like pay for the cost once while we index, and then
interesting. So meaning
we should do that.
If you have a chunk size of whatever bytes and you want to add a boolean that says this contains a
so that we don't even pay the cost. Like we can just go through a fast path for like.
So if that boolean is false, we don't even have to check because we already indexed
it. We probably would still do the chart boundary thing because like you could still land inside of a multi-byte. I don't know, or maybe not. Maybe Nathan, that's what you're saying. Like if it's just ASCII, we don't even do that. Like, it's like even. Yeah, we don't even check for the chart boundary thing at all.
I guess there are gradations, and there's more fruit to pick than just ASCII, is your point. Like there's Latin.
Right. Yeah. Exactly. Like
parts of the Unicode spectrum that don't do this graphemization. What is it called? I'm sounding really ignorant now.
Graphemes. I think. Yeah.
But I'm looking for a verb. But the composition of successive code points into a single entity. There are plenty of. It's not just ASCII. There's more to get than that.
Yeah.
Anyway, I digress. Maybe we should keep going with the main topic.
Yeah. So. Okay. So clip point. This is at the lowest level, right? And then we talked about display point, which is what's displayed, and display point is invisible characters wrapping, right? I think in display point, basically, if I do I have soft wrap on? No, soft wrap. Let's turn it on. If I have a line like this. It's a pretty long line, and you don't see this because you don't have soft wrapping on. But basically, if I move my cursor down, we're moving display rows up and down, right? And in the point that we looked at, it would be the same row, like row 987.
Oh yeah.
Well, 0 next.
Right.
This is the one time I got it right. Off by 1. I was actually right. So.
Right.
Down, down, up, up. So this is display rows and display points, right? So what then are anchors?
They're very different from the soft wrapping stuff, I think. It's all okay. Period. New topic, anchors. Just so you know, to me they're very disconnected from the soft wrap. Oh, anyway, but
why aren't they a text coordinate system?
I don't think of them in quite the same light. Let's put it that way, because an anchor is more about it's a logical coordinate. So it's a logical location in the buffer, where if you create an anchor pointing to any individual character in the buffer, right? So you can create an anchor on the right side of a character or the left side of a character, basically, that points to that character, basically. And then at any point in the future, you can always redeem the anchor and get the position of the character that you essentially marked or anchored. Even if editing has occurred in the meantime, even if that code's been deleted, that character's been deleted, you could still get the position of its tombstone, basically, where it would be had it not been deleted, or where it would emerge if that delete is undone.
Somebody should have told me this 6 months ago. Like, this was just a light bulb moment for me. You're saying it sticks to the character, right? On either side of the character, and then... Okay, so let's zoom out for a second.
Okay.
Anchors, can you both come in here and edit code with me so we kind of demonstrate the problem here? Like, if I write a comment, writing a comment while someone else is adding something. Yes, exactly. At the start of the line. Exactly. Yeah, so I'll move this.
Anyway.
Okay, so this is what we're talking about here, right? That collaborative text editor, 3 cursors moving around in the same region of text. People are editing the text, meaning they're moving us around, right? And that's where anchors come in.
Right, like if we weren't collaborative, like if you look at how selections are expressed in the editor, for example, like in the selection container or something like that, like they use anchors.
Okay.
So you can see that they're parameterized, but like the essential state we store in the form of anchors. And the reason we do that is because like if someone's editing the buffer, you want your cursor to stay in the same logical position. So if we stored numbers, your cursor would sort of just like sit there as the buffer was changing kind of out from underneath it, right?
So if I'm in line 2 and I have a selection, and then you would add stuff at the start of the line, I would be stuck in the wrong place, right? Because you would move text under me.
Exactly. But it turns out it's just like a really useful concept, not only in collaboration, but like when we spawn stuff on a background thread, we'll create an anchor relative to the snapshot so that when it comes back to the foreground, even if editing has occurred in the meantime, we can still make sense of it.
I didn't know that. Okay. So can we look at anchor, what it is?
Oh man.
I mean, high level. High level.
Yeah. But okay, maybe let's skip over the multi-buffer. I mean, we could talk about the multi-buffer anchor, but
no, let's go into text anchor.
Well, yeah, I think the multi-buffer anchor is just like
we're thinking about a different implementation long term for what we do with multi-buffers anyway, where buffers just become inherently multi. We haven't started it on that yet, but so the long term, ideally, multi-buffer won't exist. Famous last words, but
fair enough.
Yeah.
But anyway. This is like the OG
timestamp. Okay, so that's also. Okay, so basically my interpretation of this, what you just said, Nathan, if I want my cursor to stick to this A that it is on right now, while you are editing this text, it's expressed as an offset at a certain time. But the time is a Lambert clock, which means it's not wall clock time, but time in edits?
Not quite. Yeah. Yeah, I don't know what this is named timestamp.
It's not a good name.
At some point, it used to be called ID, I think, or insertion ID.
Yeah.
I think
what is it?
Yeah. Nathan, go.
So basically, in a CRDT, I think I was talking about this on a podcast, like Chris's podcast, Developer Voices. In a CRDT, our implementation of CRDT is basically implemented where every piece of text, whether it's a character or a big block of pasted text or something that's inserted, is viewed as this immutable block, and that immutable block is given a unique ID, an ID that's unique across the cluster. So it looks like a timestamp, but dive into the data type, dive into clock Lamport.
Yeah, replica
You
ID
can
and
see replica IDs are inherently unique across the set of collaborators.
yeah,
And then
just a sequence basically, a Lamport sequence number.
right. Basically, it's a way of getting a unique ID, right?
Yeah.
The uniqueness is inherited from the replica ID, and then each replica is, of course, free to generate new Lamport timestamps all day long by incrementing their sequence number.
Yeah.
And so anyway, the result of that is it's really an ID for the insertion, for the original chunk of inserted text, basically.
Okay.
And then there's an offset into it, right? Because once we insert it, it's immutable. If you delete parts of it, we might hide them, tombstone them, but they're still there. And so that's how we achieve the collaboration. Is the whole thing is monotonically increasing. It's only accreting data over time, and because of that, I'm able to refer to insertion ID whatever, offset whatever. Now there's a lot of indexing and fanciness to figure out exactly where that is right now.
Yeah.
But it's at least something we can refer to that's stable. And that's why we choose to anchor it. It's an anchor into this monotonically growing structure.
So you're saying this offset is not the offset in this buffer
Right. It's an
at a
offset in
certain
an
time,
insertion.
but it is an offset into an assertion with this ID basically in this buffer. Okay.
Which was created at that point in time. I mean,
Yeah,
that's also
yeah,
true.
yeah.
So,
Okay.
yeah, so these are really useful to have once you have that underlying ability. And what I'm really excited about is what we want to get into this summer is resuming work on CRDB, where we're actually persisting the underlying state that would be necessary to redeem these anchors, over time, so that you can create an anchor to a character, right, and come back 3 months later and still resolve it.
So that
That's
means
the
you
dream.
could replay the changes. You would keep track of all the insertions and all of the blocks, and then you have an anchor, and you could fetch that insertion thing with that given ID and see.
Yeah, you could go back to the point the anchor was created. That's one thing you
Yeah.
could do, but you could also just use the anchor as a way to annotate the code, and that's what we're moving toward, right? So that I could highlight a piece of code and say, Max, why did we rename this to timestamp? Can you explain your reasoning here? Mention him,
okay.
and then have a conversation that's just linked there. Or so that I can generate code with AI and then have a paper trail annotated on top of the code in a way that will survive over time. Yeah, so just hoisting this anchor concept. Obviously, you could try to fake it with Git diffs, but
Yeah, but
the idea of actually having the operational database track it over time, I'm really excited about.
so it's kind of like, forgive me for pulling this in, but kind of like the comments in Google Docs, where you can leave a comment on a certain thing, but you can actually add text before and after, and it
Right.
moves the comment around.
Right.
Okay.
And way bigger than that. I think it's this annotation layer for code that we're trying to build that kind of gives text this new dimension, because text right now is sort of just front to back, left to right
Yeah.
or right to left. We need to do better there, but we'll get there. But but by letting you anchor into it, you can add all these, this forest of multidimensionality to the data. What AI generated this? What was the conversation? What errors came in from CI on this code, et cetera, et cetera. It opens up the whole code base is this canvas for talking about software, which is where, that should be where it all happens, right? In the code.
Yeah.
Yeah, and to add on top of that, you said, Thorsten, these are CRDB would be having Git diffs, but I think a diff is only the difference between what was there before and what is there now. But what happened in between? a div represents like a shortest edit script. Like it's the fastest way you can take a piece of text and transform it into another. But like as a programmer, like to go from A to B, maybe it took you like 5 or 6 iterations. Like all of those are super, maybe you talk to AI, like what Nathan once said, or like, maybe you paired with someone and like they helped you kind of, edit that snippet in a certain way. So yeah, like capturing all of that. I mean, yeah, I'm so excited. I messaged Nathan, what was it, a couple of days ago? Like, it's like my brain is revving, something like that. I'm just like, I'm so excited to like work on this.
Nice.
Okay.
First, we're gonna go driving. No, we're gonna work on it. Then we're gonna go driving. Antonio's 30th birthday, and I got him. We're gonna go race Ferraris. I'm sure I'm not.
Oh my God. Yeah, I'm learning. I mean, I knew that was the idea, but yeah, I didn't know the specifics. Yeah, that's cool. Yeah, let's do it after we work in case we
Die.
Crash.
Yeah, right. Okay.
Oh.
Do a git push before, yeah.
All right, sorry, we're way off track from coordinates.
Yeah, okay, so let's go back to...
But now you see why anchors are a whole different topic, right? And how they're different from offsets. Offsets, and to sum up how they're different, points, UTF points and offsets and UTF-16 points and display points, all those things are valid at a particular moment in time. Anchors remain valid in perpetuity going forward. So you can always redeem an anchor for a position, and that's what makes it special and different. Yeah.
It's kind of orthogonal, yeah. What other coordinate systems do we have? Points, we have offsets, we have...
Yeah, let's go through them.
Yeah.
Like if you go in display map, you can get a gist of like
do we
all
need
the...
to get into the display map? Like, do people care about this? I mean, some do, some don't, I guess, right? But
I mean,
these
maybe
are implementation details, I feel like, of the display map. It's interesting, but it's not really required to like do work inside of Zed, but it is interesting. So we could look at it real quick. Let's see. We looked at this before.
Yeah. Well, I think this kind of, shows like the various layers of transformation. Like, we go from a buffer, like then we inject inlays. So this is its own coordinate space that's only additive. Like this can only add because inlays don't delete text. Then there's folds. So this is like a coordinate space that kind of, I guess, gets something from bigger to like one character, like an ellipsis. Then there's tabs. This expands the tabs. So this makes it expands as well. Then there's a wrap map, which
additive.
I guess additive inserts these like fake new lines
indentation.
And then there's the block map, which inserts things like we use the blocks for like inserting arbitrary elements in the natural flow of the text. So like errors, for example, would be a block. Like when you do F8.
I here produce an error, and then...
And do F8.
Yeah, here, this is a block, right?
That would be a block.
And if I move the cursor up and down, it hops over the thing, right?
And
that's clipping in place, yeah.
And we actually rendered two or three synthetic new lines there. To punch a hole in the text. We just pretend there's new lines inside there. So as a consequence of that, blocks always have to be the height of full lines. That's a limitation right now. I think maybe there's a more sophisticated approach we could take that's not based on that. But there's also something to be said for vertical rhythm and just staying in the line grid with what we're doing.
Yeah.
So far it's worked okay. But anyway, we're kind of handling it at the textual level, if that makes sense. So you can be any height you want so long as it's an even multiple of the line height.
And then text is highlighting, syntax highlighting?
These are not about, coordinate space. Like, I think these are kind of
right?
weaving in, like highlights that we want to, basically like this map can spit out kind of chunks of text and optionally you can highlight some of them. Then there's creases.
Those are new.
Yeah, that's, and
show how they're used.
Yeah, they're like we're using them in the assistant panel, which we want to rename to context panel. But the idea is that when you insert / command, we kind of create this crease, which is basically a region that can be folded, and optionally, like a crease can also specify like what element do you show as a placeholder when that region is folded. So Thorsten, you could probably show that like in the assistant panel right now. Like if you say, I mean, default right there, that's a crease. But yeah, active, for example, that's cool. So yeah, like see on the left how we're creating that chevron. Like that's indicating that there's this. That's a crease. Like there's a range in this assistant panel's buffer that can be folded, and when you fold it, the crease specifies like the element that you see, which in this case, if you click on it, would be the name of the file plus that icon.
Got it. Okay, so that's, and it can also contain other folds, right? So that's also why.
Yeah, those nest. I think folds in general can nest. Like the crease map is basically it just it's a bunch of recipes for creating folds. So the heavy lifting, most of it is done by the fold map, which
Okay. All right, so on the basic types, though, we do have point. I think we have well, there they are. We have offset, which is not UTF-16 offset, right? We have offset UTF-16.
Right, yeah.
A lot of times we just use U size for offset, or we completely replace it across the board. Maybe we have.
Yeah, I don't know.
2 months ago. No, that was kind of doing Vim stuff, but
yeah, I've definitely used U sizes as of last week, so we still have them.
Okay, so U size, basically what I'm doing here, right, where these offsets are just U sizes. I guess I don't know what ranges returns.
It's generic. So
it's generic.
It's anything that's let's look at it.
Text dimension here. There you go.
Yeah.
Text dimension what's up the output.
Yeah, and the text dimension is basically, I think, I don't know
where you find the list of these things, right?
Right. Like I think anything that implements that exactly is going to be that.
Ah, right. Yeah.
Because what does it mean to be a text dimension? Let's see. So it's something that can be converted from a text summary. Okay. All right.
Text summary. Yeah, I mean, here we can see it here. Like we have length in UTF-8. Like this is all the stuff that we saw when looking at the rope again. So this is all the things that we can index by.
Yes.
So there's like, offsets.
We have it implemented for U size.
Yes, these are the only coordinate systems that really exist other than the display layer coordinates, right? Which are all about, those are about the editor.
Interesting. Okay.
Right.
But when you're working with just the buffer, it's just, UTF-16 offsets, points, and byte, like UTF-8.
UTF-8 bytes.
Yeah, and point UTF-16, which I guess is just a twist on...
Yeah, I think we can derive that with the combination of like the offset UTF-16 and the normal point.
Yeah. Okay, so Nathan, you would say the only text coordinate systems we have is points and offsets, and
I mean those are the major ones, and then we have the bespoke or like the special UTF-16 stuff, which is there for like interacting with language servers. And then of course if you're doing stuff in the editor, you're thinking about display coordinates. You don't need to think about every little stack in between there, but just sort of like, is it a display point or not? And that depends on what you're doing, which makes sense. Like if you're doing something kind of editor oriented, like moving the cursor, etc., then you want to be thinking in display terms. If you're more closer to the file and you're like thinking about syntax and that sort of thing, then you're probably using buffer coordinates. And the challenge is that what you're really using is we have kind of buffer, and then we have a wrapper around buffer called multi-buffer. Basically to make multi-buffer editors work, we sort of put a multi-buffer. We make every buffer a multi-buffer, just some are singleton. So that adds a little bit of like, complexity. What we're wanting to do going forward is add a new construct called a portal. And a portal is basically a way of injecting an excerpt of one buffer inside of another. And then I think once we do that, that kind of subsumes multi-buffers. I think some of the cases where we're using multi-buffers, there's obviously going to need to be, like, in those cases, we really don't want we have kind of like a buffer that's the parent buffer that's anonymous that exists only for embedding portals to other buffers. And we don't really want you to be able to edit the foreground buffer, so we'll have to arrange so that that happens. But I think that's doable, and we can strip out that like kind of non-compositional layer of the multi-buffer. Yeah.
Nice. So the multi-buffer will basically as it is, would disappear, right? And then...
That's my hope. I'm not sure when that happens because it's a big job, but hopefully as part of the CRDB work and introducing portals, which is a big part of the work we're doing around AI, of like, when you inject into a context window a little piece of text, I really want that to stay synchronized. It'd be nice if you could just edit it right there. That's all going to be supported by portals. So like, hopefully once we have those portals, we won't need multi-buffers. But
it's interesting how much, we're talking about collaboration, AI, a high-performance text editor, rendered at 120 FPS, but how much still is about text and like positions in text, and you have portals, and you take one bit of text from this, and you put it in this. I mean, it's a text editor, but still, like a large part of it is just handling text and displaying it. And
indexing it, transforming it. Like text is the ultimate user interface because it's so flexible. But that's what makes it hard to build a good UI around text because it's so flexible. It means you need to be incrementally parsing it because it could say anything, and interpret \t as this like cue to inject synthetic space.
Do we have anything else? I think we covered everything, actually. I mean, obviously, there's 10,000 rabbit holes we could go down. But
and we went down a couple of them.
All right. I think we got everything.